Hi, welcome back. It's Mark from embeddedpro. I'm continuing my series investigating the ARM Cortex M33 core by taking a deep dive look at the LPC55S69 from NXP. This week, I'm continuing looking at the flash programming by looking at the in-application programming ROM inside the LPC55S69. This ROM code helps us with programming and erasing flash and doing other interesting things with the flash memory. Let me start by looking at the ROM code that's inside the LPC55S69. Well, let's begin by looking at the documentation for the in-application programming ROM. And this is in the user manual for the LPC55S69. So let's open that now. And here I am in chapter 9 of the user manual. It's the Flash API section. It's a very convenient drawing that shows us the user ROM inside the part. And we can see it's at base address 13,001,000F0. At this address is a set of pointers that are pointing into other parts of memory and give us access to the various functions that are available to us. I have this drawn out in PowerPoint where it's a little bit more convenient to see. And here is the ROM pointer table inside the LPC55S69. Again, it's at base address 13,001,000F0. And at that base address is a pointer to the code that will run the bootloader. And if we ever need to run the bootloader from our application code, we can extract the address that we need to jump to from that pointer and jump to that address, and that'll run the bootloader. When we want to see the version number of the ROM code, we can read the version number from address 13 million or 1000 F4. There are other drivers pointed to by this pointer table: the flash driver, the IAP API, the LPC USB driver, the low power driver, and the bus crypto engine. Today, our interest is going to be really in the version number and in the pointer to the flash driver. Let's just take a deeper look at the flash driver. Again, the flash driver here at 13,001,000 FC, it's just a pointer to a set of further pointers. We can read the version number, we can call the flash init function, we can call the flash erase function, and so on. There are many functions available to us, and I ran out of room, so this table goes up above the top of the table with many more functions that are available. As always, let's transition into MCU Expresso and take a look at the ROM APIs in action. Well, here I am in MCU Expresso IDE, and a couple of things to point out to you. First of all, I'm using IDE version 11.0.1. That's currently, in November of 2019, the most up-to-date version of MCU Expresso IDE. And I did receive from NXP earlier on this week an email that told me that the SDK for the LPCXpresso55S69 has been upgraded to version 2.6.3. This is the very latest version of the SDK, and it supports the wonderful new feature in the LPC55S69, and that is operation at 150 MHz per core. That's really good news from NXP. So in my MCU Expresso IDE, you can see in my installed SDKs, I've got the latest version SDK, LPCXpresso55S69 version 2.6.3. I recommend you go download the latest version of the SDK and always try and keep it up to date. I've imported the Flash IAP1 example SDK project into MCU Expresso. This is the project which demonstrates how to use the flash driver from the SDK. First of all, let's look at that flash driver. So I'll open up the driver group, and here is the driver FSL IAP.C and FSL IAP.H. Let's take a quick look at IAP.C. Here it is open in the editor. Well, the first thing that we notice is this hash define ROM API tree. This is a pointer at address 13,001,000 F0. As we know, that's the base address of the ROM API tree. We saw that in PowerPoint a little earlier on. At the ROM API tree address is located a structure of type bootloader tree type. Let's take a quick look at that in the outline view. Bootloader tree is here, and what we see here is a set of pointers: the run bootloader pointer, a copyright pointer, and the flash driver pointer. And these are the pointers that we saw in the ROM tree in the PowerPoint presentation. There's a pointer to the flash driver. It's this element of the struct. And let's go and take a look at that. It's of type flash driver interface type. That's defined here. And it's a long struct of pointers. We can see the implementations for each of the functions provided by the ROM flash driver API. There's a flash init, a flash erase, flash program, and so on. It also shows the calling conventions. Now, fortunately for us, NXP have provided us with a flash driver, and all the functions that we want to use are provided for in the API, and we can see these functions here. There's a flash init function, the flash erase, flash program, flash verify erase, and so we can use these functions without necessarily needing to know where the functions are placed in the ROM. And of course, the example project in the SDK is just showing us how we use these particular API calls. Let's see that right now. So we'll go into the source code for the project. The source is in this module called IAP in application programming _flash.c. And just like any other project, we hash include the drivers that we need. Here we're hash including the FSL IAP driver, the flash driver, and the project will go on ahead and set up the board, set up the clocks, sets up the pins, the boot clock, and sets up the UART for debug console. And then the project illustrates using the ROM APIs for the flash driver. We see here flash get property, flash init there at line 59, and the example goes on and programs and erases the flash. Here we can see the flash erase call, and then a flash verify erase, and then a flash program. And one thing of note, the flash program is actually copying a buffer. It's the S buffer here, it's a global, and copies that into flash. The buffer is defined at the top of the code here. Here we can see the buffer. It's a uint32 type. It's a buffer of length 512 bytes. And only the 4 elements, the first 4 words, have been initialized. When we see the flash programmed, we'll see the first word 1, second word 2, third word 3, and fourth word 4. All the other words will be 0. But it's best to see that in action, so let's start a debug session and see the code executing. So the first thing that I want to do is have a look at those ROM pointers that we saw earlier on. And if we remember, they're in memory and they're at address 0x13 10F0. So just open up a memory monitor. And what we see here in the memory window is a set of pointers. So at the base address for the ROM pointer table at 13,010F0, we see a pointer to the run bootloader function. Of course, this is still in secure ROM. After that, we see the version number and then a set of pointers into the ROM. Okay, well, let's run the code, and I'm going to run down to just before we call this flash init function, right click, run to line. We'll do that. So we've run through the configuration, setting up, and the printing of the project name. So let's step into that function now. I can do that, step into, and here we are in flash init. If you remember, the first thing we do is return the major version number from the bootloader API tree, and that's going to return the major number just here in memory. Let's step over. It's using this global variable S version major to store the .major version from there. Let's step over that. We can now see that S version major stores the value 2, which came from this major version number just here. Okay, let's step out of that. Okay, we've initialized the flash. Let's step on. Let's now step over these flash get property function calls, where we're going to return the block base address, the sector size, the total size, and the page size. And now, of course, we're going to print them out. Some very useful information for us as software engineers. We can see the block base address. We can see the sector size is 32K. The total flash size is 640K. And the flash page size is 200 hex. The rest of the application just calls the flash erase and flash program function, and is setting up an area of flash right at the top of flash that can be erased and programmed. So let's call the flash erase function. Just going to run to here. Let's step over that. The flash is now erased. Well, what destination address is going to be erased? Well, it's address starting from 9DE00. Let's take a look at that in a memory window. 0x9DE00. We're going to program some memory now, so let's run to there. And we've got a buffer called SBuffer that's been populated with some data. We're going to copy that into flash. Step over. As we program the flash, we saw that the memory window updated, and here's the beginning of our buffer 1, 2, 3, 4 that's been programmed into flash. We're going to verify it, read it back. This is a manual way of verifying the flash, and then finally we're going to end up spinning in this loop. Okay, that's all for now. Let's terminate our debug session. Close project. And that's it. Let's head back into PowerPoint. Well, that completes our look at the Flash API in the LPC55S69. I hope that you enjoy these videos, and if you do, then please subscribe to my channel, like this video, and share it with your friends. Thanks for watching, and I'll see you next time. Goodbye.